Standard operating procedure is a document that states what steps will be taken and how they will be carried out. It's very important to follow the exact steps written on the standard operating procedure because it helps us to guard against the normal human desire to take shortcuts based on assumption that might be false. So an example of the what might be stated in the standard operating procedure is how we should collect the sample and how should the sample look like and what should we do if we see anything that might be faulty in the sample. For example, if you collect a sample that is homogeneous and then after keeping the sample for some time, you see that there is a precipitate in the sample. That's before you start your analysis. The standard operating procedure could then dictate that you may reject the sample if there is any turbidity or if the sample is not homogeneous or if there is any precipitate. So you must carefully read the standard operating procedure and you must follow it. Also, standard operating procedure will specify how instruments are to be maintained and calibrated to ensure their reliability. In order to monitor the accuracy, precision, or instrumental performance, a control chart can be created for the analysis. So what is control chart exactly? A control chart is visual representation of the confidence intervals for measurements having a Gaussian distribution. So um, let's have an example to see how a control chart is created. So let's say that there is a manufacturer who make vitamin C tablet. And the vitamin C should contain the average, which is the target value, which is the mu milligram of vitamin C per tablet. So you start to take randomly 25 tablets of the vitamin C that is produced, the tablets from the factory. And every hour you take 25 different tablets and you start analyzing them. And you repeat that hourly. And then you report your results for the average or the mean of your measurement every hour against the value you get. So you report it as time against the value you get. Normally there are 5 lines for your control chart. The first one is the target value, which is the intended value for the amount that should be there in your tablet or whatever the type of analysis you are doing. And then we have what's called warning lines. There are 2 warning lines, upper warning line and lower warning line. So the upper warning line, the value will be the average plus 2 standard deviation over the square root of the number of measurement, which is 25 in this case. The lower warning line is again the same, but it's minus 2 standard deviation over the square root of the number of measurement. It's very important to understand that for Gaussian distribution, 95.5% of all observation should lie between these 2 warning lines. So this is 95.5%. There are also the upper and lower action line. Upper and lower action line, the value here is standard is the mean plus or minus for the lower action line, 3 standard deviation over the square root of n. For a Gaussian distribution, 99.7% of all the values should be between the upper and the lower action line. So only 0.3% are expected to be above or below the action lines or out of the action lines. So normally when you do your measurement against the time, you start to monitor your results and how they are distributed between all of these lines. If there is anything that will indicate non-random distribution of the results, we should immediately any random pattern, we should immediately stop the process and shut it down for troubleshooting. So let's have some examples of these non-random distribution or non-random pattern of our results. First of all, if there is even one observation that is outside the action line, whether here or there, one value that is outside the action line, we should completely stop the whole process and we should regard this condition to be unlikely because as we said, it's 0.3%. So if we are doing 25 measurement, then um, if one of the measurement, we do this against time, I would say we did that like 20 times. Okay, so if you get one of these outside, it's very unlikely to get that out of 20 or 30 measurements you are doing. So this is very unlikely. If you have 2 out of 3 consecutive measurements between the warning and action line, because the value between warning and action line is still very low value. So if you have 2 consecutive, it's very unlikely. So this is why you should stop the process. If you have 7 consecutive measurements all above or below the center line, regardless where they are, so whether they are between the target value and upper warning line or between upper and warning or upper action line, if they are all between the target and the upper lines or between the target and lower line, then this is not a random distribution. This is definitely, there is a pattern here. Also, if you do have 6 consecutive measurement are all increasing or decreasing regardless where they are. So if you have values, for example, like these ones, 1, 2, 3, all increasing regardless where they are or decreasing on the other side. So this is not random. There is continuous increase in the value. So this is not random. If you have 14 consecutive values that are alternating between increasing and decreasing, then this is again, it's very clear that this is not random. Generally speaking, as I said, if there is anything that looks not random, then we should stop the whole process and we need to shut it down for troubleshooting.